This is AS2 Physics 2 Jun2005, and this question is on refraction of light. Figure 2.1 shows a ray of light in air entering a block of transparent material at an angle of incidence I. Inside the block, the light travels at a speed of 2.20 by 10 to the power of 8 meters per second. The width of the block is 150 millimeters, and the ray travels through the block at an angle of 35 degrees to the normal. The first question asks us to calculate the refractive index of the material in the block. Well, we have to think about what information we've got. The first piece of information we have is the speed of light inside the block. We have the width of the block, which is of no use to us for refractive index, but we have the angle at 35 degrees to the normal, which is the angle of refraction in the glass block. However, if we want to use the angle of refraction to calculate the refractive index, we must know the angle of incidence, and we don't know that. Therefore, we're going to have to use the equation n equals c1 over c2. Now, c1 is the speed of light in a vacuum, which we know is 3 by 10 to the power of 8. The question then tells us c2, which is the speed of light in the material, and it tells us that it's 2.20 by 10 to the power of 8. Therefore, the refractive index is 3 by 10 to the power of 8 divided by 2.20 by 10 to the power of 8, and if you calculate that, it's 1.36. Now, the specification does say, or the mark scheme rather, does say that the answer should be to 2 decimal places in the mark scheme, although it doesn't tell you that in the question. Therefore, your answer is 1.36. If you did round that to 1.4, you would lose a mark. So you would have a mark for your calculation, a mark for your 1.36, and a mark for your 2 decimal places accuracy. Okay, moving on to the next part of the question. It asks you to find the angle of incidence at which the ray enters the transparent block. Well, we now know that n is 1.36, and incidentally, if you do make a mistake with that, when you carry that error through, they still give you the full credit for the next question if you use it correctly. So n is 1.36. We know the angle of refraction is 35.0 degrees, and our equation then for refractive index, n equals sine of I over sine of r. So we can either rearrange that before we start or substitute and rearrange it. So substituting and rearranging, right over at the right hand side here, equals sine of I over sine of 35. At this point, do make sure that your calculator is in degrees and not radians. Also, when you rearrange that then, 1.36 times sine of 35 is equal to sine I. I would recommend that you don't write down the result of this calculation at this point because you'll lose accuracy. Simply retain it in your calculator and inverse sine it. So the inverse sine of 1.36 sine 35 is I, and that works out to be 51.3 degrees. Okay, you would have a mark for your equation, a mark for rearranging successfully, and then a mark for your final answer. Now it asks us to calculate the time it takes for the ray of light to travel through the block. Well, we know an equation which links speed and distance and time. Speed is distance over time. The speed of it through the block, the question gives us 2.20 by 10 to the power of 8. It also tells us the distance light travels, kind of. If we look at this diagram, the question does tell us here the speed of light, so we can use that. We need to find the distance light travels. It tells us that the width of the block is 150 millimeters, which is 0.15 meters, or 150 by 10 to the minus 3. That's this distance. We want this distance. So if I call this distance x, is the distance the light actually travels. Therefore, we have to use trigonometry to find that. When we're using trigonometry, this horizontal 0.15 is the adjacent side. The x is the hypotenuse side, so adjacent and hypotenuse, we're going to use cos. So cos 35 equals 0.15 over x. Therefore, x equals 0.15 over cos 35, and that works out to be 0.183. When we come down then to the calculation at the bottom, we put in our 0.183 divided by the time. So the time is then 0.183 divided by 2.20 by 10 to the power of 8. And we get a time then of 8.32 by 10 to the minus 10. And again, we're following that 2 decimal place recommendation from the earlier part of the question. The marks for that question, you would get a mark for calculating the correct distance that the light travels, and then a mark for your answer. That was quite a short question on refraction, but it did cover quite a lot. It covered calculating the refractive index using speeds that the light travels. It then used that to use the other refractive index calculation. Refractive index is sine of the angle of incidence over sine of the angle of refraction. And then had a little bit more application of your knowledge in terms of the speed as distance over time and using trigonometry.